So it's a great pleasure to be here with you today. So because what you represent is what I always dreamed for. So basically a society that is not only sitting on the couch and watching a TV, but being able and going on the other side and build the TV screen that you have, or just a mobile phone or whatever technology you may like. So of course you represent the tip of the iceberg because you are ASIC designers. I don't know how many people of you are designing ASIC. If you can raise your hand, people that are designing chips. There are people that are working with software, hardware, AI, benchmarking technologies. I was looking at the proceedings. I said, okay, I don't understand like 50% of this thing, but it seems quite interesting. So it's a big honor to be here with you. And thank you very much for the invitation that I really, really appreciate. So today we're going to cover a little bit of historical things about Arduino, so some curiosity that you may not know. And also we go a little bit more deeper into the technology, transformation of the enterprise. But what I would like to do is mainly not really just a frontal presentation, but I would love to hear your voice, ask your question, whatever curiosity you may have. I may not be able to answer if you ask me about FPGA, the latest model of FPGAs, but I can try to answer as much as I can about all the general topics that we are going to cover. And feel free, of course, to contact me on LinkedIn. Don't expect like prompt responses from me on LinkedIn because I have like 12,000, 13,000 people writing to me every day, especially Chinese and PCB makers. So I have a specialty about collecting all of them, but I will try to answer to as much as I can. So you know Arduino. How many of you have been using Arduino? So basically the majority of people, but many people don't know that Arduino is a company. So they think it's a charity, sometimes they think it's a technology, a category of the universe, whatever. But Arduino is basically the company behind the largest open source embedded computing ecosystem in the world. And I will quantify this during the presentation in terms of statistical data. So I will go a little bit fast because we have 45 minutes, so I want to allow even more time for questions, so I will try to be shorter. So it is a company that has been incorporated in 2008, and we design, manufacture, and distribute all the products and support all the products that you have been used, either original products or, let's say, mainly clones, in some cases counterfeits that we hate. So the difference between clones is that clones are legit because we are open source hardware. Counterfeits are the people that take our logo, trademarks, and all the intellectual property that we have that is mainly in the form of trademarks and put it on their own board, calling it Arduino on Amazon. So some of you may have started this journey with the famous Arduino Uno, the product that you see on the right-hand side. But there is much more. So today Arduino is a company that has some external investors because, of course, you will learn it yourself when you start your own company. Hopefully 50% of this room will start their own company, but you need money. So this is like a simple law. And we were really lucky because we got a pretty interesting set of investors, of which we are super grateful to ARM. And I will tell you why. That was the first of our investors. So basically the first company that really believed in Arduino. Then we have Anzu Partner, it's a venture capital from San Diego. Robert Bosch Venture Capital, now called Bosch Ventures. CDP is the sovereign fund in Italy, for those of you that are from Italy. This is an interesting, let's say, investor because they have a lot of expertise, especially in semiconductor. They invested in Seco, they invested in Arduino. The guy that is running the fund and is our board member is also a former NXP employee. So basically, you don't have to explain what you do. That's a good first step. And then we have Renesas, that is a semiconductor company that basically believed in Arduino from the very beginning of this new Arduino that we are talking about today. So you saw the Arduino Uno R3. Product that has been on the market for 13 years, but now we have the Arduino R4, that is the one that you see here. And basically it's a quantum leap because we went from 8 to 32-bit. It seems like odd in the context of your conference where you talk about hyperscaling microprocessor running language models with accelerators, but in this world, having a 5-volt compatible microcontroller is a quantum leap. So we were lucky enough to find a nice part from Renesas that we put on this board, and it's Wi-Fi enabled, etc. But the slide is not about the Arduino Uno or 4, but it's about our mission. So the mission of Arduino, believe it or not, is to empower anyone to innovate by making complex technology simple to use, because you are an elite. So, but as an engineer, I think we think always that we can control everything about, you know, the products, the success of a product, etc. But that's not the reality, because we may be technically savvy and expert on making things work, but the other part of the equation are people that are buying those products. So what we call technically the product market fit is more important than the product itself. So you can invent the product. So I was chatting at dinner with one of your mentors, and basically he said we had a company that was struggling, but we had a product that was very meaningful for a chunk for a segment of the market. We cut all the noise and focused on this product, and we sold the company because of this product. So this means they found a product market fit that is important. So, but in order to find a product market fit, you need to get opinion, feedback, and point of view from all the possible audience. And the audience of the technology that you develop is not always engineers, because of course, if you think about, you know, the development kit that you get from silicon vendors, how ugly are they? So you can really literally spend 1 week just to switch on a development board that is a kitchen sink of sensors, chips, whatever, just JTAG, compile the operating system, all these things, and just 1 week lost of your life, lost just to get a development board working. So think about a cognitive psychologist, a philosopher, an architect, a designer, a, you know, whatever, a language expert. They don't know anything about that, so they don't know what is JTAG, they don't know what is this thing, but they may want to use computing applied to real life and create something new that you never imagined could be possible, helping you as engineers to find the infamous or famous product market fit. And this is where Arduino started, because Arduino started in this place called Interaction Design Institute of Ivrea. You are young, so I think some people have gray hairs here. They may remember this brand called Olivetti. And Olivetti is a European company based in north of Torino, 40 kilometers north of Torino, the place where we manufacture the Arduino product, where you raise your hands. And Olivetti, we will go into Olivetti details a little bit in the next slides, but was a pretty visionary technology company. So they started with typewriting machines and transformed that space radically. Think about Apple and the Apple Store. This was made by Olivetti 40, 50 years before the Apple Store. So this is a visionary technology, a company that we will talk about. But they also moved into computing. And this building was one of the former buildings of Olivetti that has been almost destroyed by the latest management when they took over. But this was the ergonomics building. So basically in this building there were people coming from different disciplines in the world working on the usability of the Olivetti products. They were not only technically advanced, but they were also very human-centric projects. And this was a place where there were like psychologists, cognitive psychologists, and this type of skills that were working on typesetting machines, and then they were working on the computers that Olivetti was making. When Olivetti faded, one person that was the wife of an Italian senator, the wife of Senator Franco De Benedetti. She was often in New York. She was exposed to the technology scene in New York. And she said to her husband, I knew that there is this new thing called interaction design, physical computing, Physical computing means adding a brain to a physical object. It could be a design object, it could be a lamp, it could be an air conditioner, whatever. So basically, she wanted to do a school similar to the thing that she saw in New York, but for Europe. So they picked this building for historical reason, and she found the funding, and she found the initial faculty crew that they hired. So this was basically an international school built in 2001 in Torino, talking about something that today is the new normal. But at that point in time, it was like coming from Mars, because you think about, combining computing and design in the country of design, where design was stupid, because basically it was mainly just the aesthetics and the functionality of product, but there were no computer in lamps or no computers in washing machines. So basically, the faculty was very international, and at that point in time, when they created this school, I was doing my PhD program. So when I did my PhD, at Politecnico di Milano, I don't know if one of you is coming from Politecnico di Milano, but we had to do 3 theses. We had the master thesis, and we had the major thesis, and then we had the 2 minor theses. My major thesis was on human-computer interaction for safety critical system. So as PhD student, we visited this school that was pretty advanced, and then the school was circling around physical computing. So there was a physical aspect that was totally covered. There were students coming from all the different backgrounds, philosophers, psychology, cognitive psychologists, engineers, etc. But they were missing one point, the computing part. So they were missing the professor of electronics in this school. So, of course, I was coming from Politecnico di Milano, super known institution in Italy. Say, okay, but probably you know electronics. So they said, why don't you teach electronics to our students? So I was not involved with Arduino by any means at that point in time, and Arduino didn't exist as a company, as a founding team, nothing. So that's the reason why I say I'm the grandfather of Arduino, because I was there, and I told the director of the school that, of course, I can go to the whiteboard and design all the possible configuration of operational amplifiers. I can talk about, avalanche effects in all the transistors, but I've never seen a circuit in my life. So basically that could have been a little bit of an issue, having me as a professor. But basically I told her that I knew somebody that could be the right fit for what they were looking for, because they were not looking for like a super exceptional professor of electronics that is designing the next generation of photonics device, but they were looking for somebody that had a practical knowledge of circuit design, but also understanding the design and understanding the cultural fit, the interaction design, etc. So basically, I introduced them Massimo Banzi, that was my friend in life. So he was one of my best friends in normal life. He was the CTO of the first Italian service provider. That was Massimo Banzi. And Massimo did study at what is called in Italy ITIS, so basically it's a technical school. It's like a vocational school where they do a lot of practical circuit design and all these things. So Massimo as well was working for Sapient in UK, so he knew a lot about design, about interaction design, the importance of user-centric design and things like that. So basically Massimo was hired in the school, and he brought together a team because they had a problem, again, product market fit. The problem they had was few students were coming with a clever idea. Let's do a smart wallpaper. Okay, this nice idea. Or let's make a smart lamp connected on the internet where basically you can transfer the emotion over the internet. There was internet at that time, but how do you do this? You have to design a custom circuit for your wallpaper, a custom circuit for your lamp. So from idea to realization, it took forever. 3 months getting prototypes done, finding the right microcontroller. Every project had its own microcontroller in case there was a microcontroller involved. Electronics never worked because these students were not electrical engineers, and so on and so forth. So they decided to come up with a single platform that was not even called Arduino. It was just what we saw at the first slide as Arduino Uno, was like the starting point of a common platform based on microcontroller. Of course, they selected the simplest microcontroller they could find, so the 8-bit Atmel microcontroller that became super famous thanks to Arduino. But it was easy to understand because the instruction set was simpler, was 8-bit, was very robust, so tolerating a philosopher connecting an LED straight to the pins without burning the microcontroller and things like that. So they were lucky to some extent. And they also made some mistake in the design. So when you look at the shape of the Arduino connectors, these are by mistake. The reason why they became so famous is basically the value they were adding was so high that nobody cared about the fact that you cannot plug this thing on a breadboard, making people crazy for the rest of the year. But this was a mistake they made in the original design because they didn't care. They were just connecting jumper wires. There was not even a breadboard concept when they designed this product. So he put together this team that you see here, of which Tom Igoe is still one of the co-founders of Arduino and shareholders of Arduino, based in New York. He works for the New York University, teaching physical computing. And then the other two people with the bird, so David Quartielles was a student, and David Mellis was a student. And this guy on the right-hand side is no longer with Arduino. It's a little bit of complex situation, but basically he was the technician manufacturing the Arduino product locally. So the two guys there were very important in the story of Arduino. So let's start with Tom. Tom is the advocate of what you see as the clear and easy to use documentation of Arduino, the API. So he's the guy that put some, let's say, absolute rules in the way they were describing what they were doing. So he said, no acronyms. We have to describe everything. The API needs to be understandable. The code needs to be written in this way. And he wrote a guide on how engineers have to go. He's not an engineer. And he said, this is the guide on how engineers have to document their code. David Quartielles was an expert, simply for personal reason, of open source. So basically, he was the Che Guevara of Arduino, so advocating not only for software open source, but also for hardware open source, pushing the boundary and saying, okay, this thing needs to be open because we want this thing to spread, to go wherever they want. Under development countries, developed countries, they have to be able to produce the Arduino products. And David Mellis is probably one of the best software engineers that we have in the world. Today he's a product manager of a product that probably you use every day that is called the Tinkercad from Autodesk. So this guy who developed the Arduino IDE in 12 hours. The first 1.0 version, I don't know if it was 0.1 version, was developed in 12 hours. And the last guy, as I mentioned before, is the guy that was manufacturing the boards. So basically this is the question that they were trying to answer. So what if cheap open source hardware opening up electronics to everyone? Because I just go back and when I said you are an elite, so you have master's degrees, you work for the best, universities and research centers in Europe or in the world, but the rest of the world is billions of people. So how do we make this thing available to everyone? So this was the question that they had in their mind from the beginning. And I go back for a second to Olivetti, because Olivetti was very, very important as an influence from many point of view, from the design point of view, but not design per se, but the interaction design and the functional design. If you look at the typewriter on the right-hand side, it's called Valentin. This is a typewriter that had a plastic case. So the designer of this typewriter was one of the best Italian, is like an archistar today, so equivalent of what you see like Zaha did or these kind of things. But they had a challenge because the journalist had to use the typewriter reporting from wherever in the world, from the war, from the curbs of New York, from wherever. So he designed the case in a way that you can just remove the case, and was designed and made in a way that you can sit on the case of the typewriters. There was the first personal computer, and they had to find crazy solutions in order to make it affordable. And by affordable, I mean something that was ultra expensive as well. But this machine, and you have to study it, is called Programma 101. They had to overcome the problem of the expensive memory that there was at the time, the point in time, because they had these ferrite memories. So what they invented is a memory based on a piano string. So they basically created a sort of spiral based on a piano string, and they were injecting some beats using piezoelectric speaker, and then a piezoelectric microphone to measure this thing. And the string was resonating, so it was keeping the beats working, and sometimes from time to time they were renovating the beats by pushing again the signal, synchronized when the signal was coming, and was hosting a few bytes of memory. In this machine, they invented the predecessor of the floppy disk. So the guy that designed this machine, they were putting like a magnetic band on a piece of paper, and they were writing the programs of the Programma 101 on this magnetic thing that became the floppy disk. So this was the kind of advanced technology they had at that point in time, an invention that they created. But it was a combination of design culture, human-centered design, Italian legacy for craftsmanship. The other source of inspiration for Arduino was also this company that you know probably because you have a razor from them or some other practical home appliance, like the company was called Brown, and Dieter Rams was the head of design for Brown, and they had the same problem we have today, skill shortage. Okay, so how do you train hundreds of engineers in Germany coming from the farms and going to work for Brown about electronics? So he invented this system. There was basically a block systems where you have a block that is a transistor, you have a block that is a generator of current or whatever. So you have all these blocks, and these were using in the training centers of Brown, but look at the aesthetics. Could be an Apple product of today, okay? So this was invented like 55 years ago, or even more, 60 years ago, by Dieter Rams. So this was another source of inspiration about simplicity, ease of use, and functionalities. And of course, there were some other things, like this book that is free. You can download it from GitHub, from this guy, Eric von Hippel. So, and this is a book about human-centric design and the process of democratizing innovation. So this is something that was very influential for the entire founding team of Arduino. So, but you don't know where the Arduino name come from, very likely. Do you know it? So basically, when they started this project, there was no company, there was no Arduino, there was no intent of making any money about it. But then the founders had a meeting saying, okay, we did this thing, so from a few units that they were producing for their own internal purposes, they went to some thousand units for internal and external things. And then all the visiting professors from external university visiting Ivrea, they were bringing this open source hardware to their countries. So from Guatemala to New York to wherever in the world. And they were starting manufacturing these Arduino clones, legit clones. So boards that were designed to be cloned, and they cloned it. So went from 0 to millions of devices sold in the world. So at some point, David Mellis came with this idea of registering the Arduino trademark, or the trademark. But in order to register a trademark, you need also, first of all, you need a name, and you need also a company. So they formed the company in 2008, and then, as you will see, those of you that, but I think you're facing this also in university. So when professor comes and say, okay, we have this new initiative, how do we call it? And you come with strange names like ACACES or things like that, because you're desperate. You have to find something in 1 week, and there is no way you can find a name. Same problem applies to companies, by the way. Products and names of the companies, because everything is registered, all the domains are taken. So basically, after a desperate session, they were sitting in a bar in Ivrea, where they were making the aperitivo Milano style. So basically, Negroni Sbagliato in Ivrea. So Ivrea is a country place, so think about Milano. The opposite is Ivrea. So it was impossible to find a place. But there was one place that was making cocktails like Milano. So Massimo, by desperation, said, let's call it Arduino. Arduino was the name of the bar where they were sitting. So that's basically how the Arduino name came. Because Arduino was the first king of Italy, so everything in Ivrea is called Arduino. Via Arduino, Corso Arduino, Bar Arduino, Pizzeria Arduino. So that's the way they came up with this name. So in terms of the philosophy, basically the idea of Arduino has been always to be different from university style things, the things we teach and the things we learn. So instead of a frontal whiteboard with a lot of formulas, the idea was to first tinker with stuff, break stuff, make stuff, and then learn what you made. So basically it's completely the opposite. It's learning by doing, switch on an LED, and then understand what is an LED, what is a resistor, why do you need a resistor, why you need a microcontroller, and all these things. So that was the approach. The other thing is design. So design could be very important in terms of functional design. So if you look at the headers of our product, so the pin headers where you wire your wires, they have labels. Arduino was the first company in the world to put on a development board the meaning of the pin you are connecting, because it seems like normal today. But in the past, basically, you had to count and say, fourth pin is GPIO 25, and SDA, SCL, I2C were basically unknown if you didn't have a data sheet. So these minimal details that you see on this board are the outcome of that kind of philosophy, starting from Olivetti, starting from Dieter Rams, etc., applied to microcontrollers. And this is continuous, basically. So every product we design, even today, we do less prototype because we cannot afford. So for the original starter kit, they did like 450 prototypes of the packaging. So it's something that is not sustainable into 2025 in terms of economics. But this is the latest kit we made. It's called Arduino Plug and Make Kit. And as you can see, there is a lot of functional components and a lot of instruction that are designed in a way that anybody can use it. So, but Arduino started, as I showed you, but has been very important for the rest of the market because, for example, this is one of the first 3D printers open source. Because in the past there were 3D printers. They were costing $500,000, so probably nobody could afford besides NASA and a few other research labs in the world. But with Arduino, you had a powerful microcontroller that could be used to run stepper motors, a simple motor driver, a transistor, H-bridge, whatever you needed, and you could create something that resembled a 3D printers. From there, a $5 billion industry started of open source 3D printers. But there also the drone industry started for open source drones with Chris Anderson was the chief editor of Wired magazine. He started a drone company, and basically all the initial drones were based on Arduino, based on the work from Chris Anderson. Fast forward to COVID, Arduino has been very important during COVID. So this is a project from University of Oxford where there were no ventilators for developing countries. Everyone that had a Philips medical ventilator basically used it in Europe or in the US. So if you were in Africa or India or some places where there was no access to this technology, you could die. So Oxford University took an Arduino Nano BLE Sense, put it as the main microcontroller of their ventilator, created a finished product, bought 7,000 Arduino Nano from us, and shipped this to developing countries. And this could be a source of inspiration for you as well, for those of you that think about creating some enterprise. So this lady, so Judith Giraud-Benet, she won in 2020 the James Dyson, the vacuum cleaner prize. Is a prestigious prize for a device based on Arduino. And I think she was using the new Arduino Giga or something like that. For early breast cancer detection. This invention that has been awarded became the company where she's working now, and is a startup that received several tens of millions of euros of funding. So going to, let's say, going to Arduino today. So I took over Arduino as CEO in 2017, even though I've been working with Massimo during a troubled time of Arduino. Maybe some of you have read this, while there was a litigation between the 4 co-founders on the right-hand side and the one on the left-hand side for some trademark issue. And this is also a little bit of advice for you for the future. So check very well who you partner with when starting a company. But after this troubled time where ARM had a very important role in helping us solve this complicated situation where Arduino was stuck in terms of research and development for several years. So I took over in 2017 formally. 2014 I started working informally pro bono with Massimo. We had a pretty important journey because when I took the company, once we removed the issues, we were 16 people, so with no capabilities, no ERP, no finance department, no manufacturing capability. There was almost nothing, so only product ideation, good firmware capabilities, but still small, and good electronics design capabilities. That was the entire Arduino. So it was quite a journey. Fast forward today, Arduino is now a company that works in 3 different sectors. One is the makers, hobbyists, and what you know as, let's say, the maker fair retail public. Then there is what we call Arduino education, where we basically help teachers in using the Arduino technology, especially in the K-12 STEM kind of disciplines, where we provide content not only for students and kids and plastics and pieces and parts, robots, but we also provide a lot of content, curricular content that the teachers can just repackage, because today the issue of teachers, especially in that kind of grades, is that the students are better than the teachers. That's a normal thing, because some of them are very advanced, so we created Arduino Education. And more recently we discovered, by talking to people, again, product market fit, talking to people, what were the uses of Arduino. So I remember I was at Maker Faire San Mateo, that is one of these crazy places where you have, dragons spitting fire powered by Arduino. You have, power amplifiers, you have whatever technology, crazy technology or invention in the world, like Maker Faire Rome here in Italy. But the first customer that stopped at the first Arduino booth ever in the history of Arduino that I asked to do to the company was a guy from Nissan Renault, and he said, for our new generation of vehicles, we are prototyping the entire cockpit using Arduino Mega 2560. So that was quite a surprise for me. Then a few random visitors, then another guy came from Audi and said, oh, the entire A6 cockpit and seats movement of the Audi A6 is made using your technology, so thank you very much, because it's the fastest and easiest prototyping technology for automotive. So basically, we had also a lot of small, medium businesses that were using Arduino Uno, Arduino Mega, especially Arduino Mega, but also Nano, depending on the size and the space they had, to do machines, to do machinery, etc. So basically, we decided to create a line of products, what is called Arduino Pro. So are these products that are black, and we can talk about it after the presentation. But basically, we decided to create a line of system of modules and also a PLC, so an industrial controller, to answer this question from people that were using Arduino in production improperly, because they were using like a product that was made for one-off, like prototyping exercises into production. And it worked, because these customers have products that are online for the last 20 years and never broke. So they worked, but they were not designed for that. So we created Arduino Pro. And the last effort that we did, but is probably in terms of R&D investment, the biggest one, is what we call Arduino Cloud. So I strongly encourage you to test it. It's cloud.arduino.cc if you haven't done. Is anybody using Arduino Cloud? Just one person. So basically, I think we have to talk to our marketing director, but basically, Arduino Cloud is the most convenient way, in my opinion, and I'm a big user, so I can show you my mobile phone that is packed of application of home automation in my house, but it's the easiest and more convenient way to create your own IoT devices for personal use, for educational use, and for enterprise use, because we have different layers of service for this thing. And it's free for makers unless they have more than 2 devices where they have to start paying. So basically Arduino Cloud is a huge endeavor, because today Arduino Cloud allows you to think about the problem you're trying to solve. You decide what are the variables that I would like to send or receive from my device, and say I have a temperature, I have a humidity, I have to control a motor, on, off, whatever. Decide just the data types of the data you want, press a button, and it auto-generates the firmware that goes to your device. It auto-generates the dashboards that you can customize both for web and mobile, and everything is free. So I strongly encourage you to do this, and this is evolving very quickly towards having a data source for training your AI model. So I skip quickly because we are running out of time. So just to give you an idea of the community, because you may think we are just 200 people here, how many other people are that will raise their hand in the world? So we are talking about more or less 40 million people, 41 million people visiting our website, and 36.7 million people downloading the IDE, just the offline IDE, the one that you use from Arduino. So it is a gigantic community that is downloading our software, in some cases using original hardware. I strongly encourage you to buy original hardware for a number of reasons, including the fact that every single Arduino board is tested individually, and we use top-notch components, and we basically manufacture it in Italy, 100% in the Ivrea area where you saw the school at the very beginning. But this is the split, so United States, India, China. Probably China is #1 in reality, because China ID is mirrored in China as well. So basically what we see is the little bit of traffic that is coming from China through the firewall. But the reality is that there are some alternative sources of the IDE that are synchronized with our IDE. But as you can see, there is a lot there. Germany is very important, France, Russia, United Kingdom, Vietnam. So the ones that are skyrocketing are also these Southern Asia countries, because a lot of people are getting retrained using Arduino in Vietnam and Indonesia, in these places where China is offloading quite a bit of manufacturing for various reasons. So this is a number, so these are staggering numbers. Think about me with 200 people in the company that have to manage, the traffic of a huge website, a huge community, huge developer community, huge forum, etc. So this is basically what we do. So we have community, project tab, forum, etc. So we have the IoT platform, we have the development platform, all the IDE that you use, plus the cloud IDE. We have all the hardware. And fortunately, the community is helping a lot with libraries, developing libraries for sensors, even though the most complex libraries, when there is a crucial process, especially for enterprise application, we have an application development group in the company that develops all the libraries that you use, all the core things like I2C, all the building blocks, Bluetooth and all these things. So talking about the cloud, and then maybe we open it up for questions. So one of the things that is staggering is the number of messages that we process per week on the cloud. So even though nobody raised their hands, we have 1.5 billion messages. So this month we reached 2 billion messages per week on the cloud. So these are MQTT messages sent by random devices like the one that I have measuring whatever in the house, power consumption, or in enterprise air compressor flow and things like that. We have more than 7,000 Arduino community developed libraries that was growing like 30% year over year in the last few years. So these numbers if you think about the complexity of managing a platform like Arduino, really call for a big kudos to our R&D, because for us the DevOps is also part of R&D, managing this system that is a sort of hyperscaler kind of metrics for Arduino. Of course, this is sustained in two ways in terms of economical value. So one is the sale of the original hardware. So when you buy a non-Arduino ESP32, of course you are happy because you're paying $5, $10 for Alibaba product. But on the other side, so they are sort of doing a piggyback on all the technology stack that we are developing. So buying Arduino means you buy original Arduino, you buy a product that is designed with certain criteria, with a certain type of components, with respecting all the regulation, all the ROAS and all these things that are not trivial, that are certified, FCC, et cetera, but also you're supporting, let's say, the development of all the quantity of software and stack that we are developing. So just a quick thing about a topic that is important nowadays, especially also looking into your proceedings. So AI is very, very popular, no? So since I joined Arduino, I decided that the only way we can work at a modern company is by investing in R&D. So we went from 0 things that were more than 8-bit to having a full range of makers and industrial product based on Cortex. In some cases we do have a little bit of RISC-V, but not small things in communication devices. But now we have a full range of product that probably could be very interesting for you, like the Arduino Mega that is very famous. Now there is the Arduino Giga, that is a dual core Cortex M7 and Cortex M4 that can be used for a wide range of application, display shields. So we have a ton of hardware. And we have big hardware in terms of form factor for making, for prototyping, and we have small hardware. So what I'm having here, you see that this the size of a stamp, is this product called the Nikla Vision. That is a dual core Cortex M4 M7 camera with time of flight sensor, accelerometers, digital microphone, Wi-Fi and Bluetooth in this side. So the PCB is the complexity of an iPhone in terms of layers and complexity of routing. So, and the product you see on the right hand side is the next generation of Arduino product. So we have it here. For those of you that are interested, it's called Portenta X8. And this is the next generation of an old product that we had in Arduino called Arduino Yun, if you remember, was a combo of microcontroller and microprocessor. But that microprocessor was a router microprocessor, was a simple single core router microprocessor. In this case, you have a 4-core A53 1.7 gigahertz processor on one side, and on the bottom you have a dual core H7 microcontroller. So basically you can create a robot, an AGV, driving the motors with the microcontroller and driving the higher level logics with the thing. And this is one, because if you see there the TBA column, so stay tuned, because in the upcoming months there will be some important announcement from Arduino in this area that get us very, very close to the best in class when it comes to AI capabilities combined with microcontrollers, GPUs, running complex workloads. And yeah, just to summarize, guys, the point is you are R&D by education. You are the guy that can really create this thing in your own startup or wherever you are going to work. So it is important, at least as a single message for today, is that all the things that I said at the very beginning are as important as the technical knowledge that you are developing. So open up your mind, create teams where you have a heterogeneous team, not only in terms of geographies, because right now the world is global despite Trump and whatever he thinks about, the segregation of the world. So the world is global. I see many people from Asia, I see many people from different countries from the world, but also in terms of experience. So having interaction designers, having cognitive psychologists, having philosophers, having accountants, but enabling them in your team to use your technology and not creating this sort of ivory tower where we design products and anybody outside the circle could not access, doesn't make any sense. If you benefit from bringing this technology and the expertise and the point of view of the different teams, so many additions to Arduino products were made by the finance team. We run hackathon inside the company where chief accountant and the junior accountant are using Arduino plug and make kit to do their kit. And they say, so they tell you stupid things, but they are very important for the product, so stupid quote unquote, because at the end of the day they said, okay, the manual of the Arduino starter kit is totally unusable. So it's one of our best sellers, okay? But they said, why don't you put the ring as the old manual that they were using in the past for electronics? Because while you are working on a project, you don't want a book that closes itself because, because you end up throwing this thing from the window. So they said, okay, why don't you put the book with the rings so that it stays open on the page that you are looking at? And this has been incorporated. The next generation of the starter kit that is coming will have this type of book. These are simple things that you never think are important because you're looking at FPGA, ASIC, you know, how do I route 45 gigahertz, whatever, antennas to do radars, and you forget about the user manual, the label on the pins. So the Nikla vision has been done by a super cool engineer that was leading our hardware team. But there is no space for anything here, so there is no label. So the people break this product because they don't know what they're soldering where, they make the wrong count. So basically, although it's a piece of engineering and it works like a charm for you and people like you that have the microscope and can solder this thing, but this is meant for a large market. So even though we spare another 2 millimeters and write GPIO 1, 2, 3, 4, or whatever is needed, it seems a detail for you because you are geniuses, but for the users, this thing can make the difference between night and day, burning the board or keeping it alive. So putting a voltage regulator, so you know, because I'm not an electronic engineer, so I learned these things by screwing up many projects. So in one of the board, I don't remember which one it was, our engineer said, okay, this is a prototyping board for professional. So we need a 5-volt input that needs to be perfectly 5 volts. What happens on the market? People buy crappy Alibaba power supply where 5 volts is like a dream, and then they are 6.2, 5.3, 7.8. So we were at an exhibition, one of our partners, I cannot make the name, but basically super engineers, they burned like a couple of Arduino $200 Portenta boards because they didn't have these pure 5 volts, and it was an electronic distributor. Probably in their catalog they have 1 million of 5 volts professional power supplies. Just because our engineers said, no, this is for professional, so they want a bench power supply. So now for me it's a mantra, it became a rule in the company. So if it is not 0.24, the maximum I can tolerate is like 0.16, and then there is a buck converter and everything in each product to make the world of our customers much simpler, because our life doesn't change if we put a $1 converter on the board and an inductor. So that's the kind of things that you may not think while you study the way you're studying, but these are the details that make you night and day successful. Okay, sorry for this long excursus on the Arduino history, but I wanted to share with you, and of course I would like to open it up for questions. I know you are tired because you have been like 10 hours of hammering under your teacher's hammers on complex topics.
Thank you very much.